of the function. So try to identify and answer those questions, and try to find the most x-intercepts you can create and the most turning points you can create by changing those values, okay? So look at that. Then it wants you to do a cubic function. So we're going to change this to a cube, then plus bx squared plus cx plus c. We want to add our b slider. We added a new coefficient. So we're going to add that on there, and it wants you to play again. So all you're doing is sliding these back and forth, seeing what changes as you slide through things. Okay, and it asks you the same sort of questions. How many x-intercepts can you create? What is the most turning points? Lastly, we're doing our quartic function. So I'm going to type it in exactly as it is. So I want to start off with x to the fourth. Then I'm going to add an ax cubed plus bx squared plus cx plus d, and we want to add our a slider. Okay, so now again, we want to just like play around, see what happens. That was kind of cool. So notice this kind of looks like a parabola, but it's got this like weird dip in right here. So see how you can, and that's pretty cool, see how you can make this change. How could you slide this around so that you had as many x-intercepts as possible? I really wanted to get it. There we go. And how many turning points can you create? Okay, so then it wants you to summarize the information in the table below. So you're going to write out each function. So y equals x squared plus cx plus d. Y equals x cubed plus bx squared plus cx plus d. And y equals x to the fourth plus ax cubed plus bx squared plus cx plus d. You're going to write the degree, max number of turning points, and max intercepts. Answer the question, what patterns do you see? And then this summary is a little bit of an extension. It asks you to imagine if polynomial has an n degree, what the maximum number of turning points is and what the maximum number of x-intercepts is. So try to do the best you can there. All right, step 6, it asks you, slide down to 6. It says use Desmos to graph the cubic function, okay? And we're going to do the same. I'm going to delete everything on Desmos over here. We're going to do the same sort of thing. Oops. Okay, I'm going to clear everything out. Sorry. And then we're going to type in y equals, x plus p, x plus q, x plus r. Okay, so we have 3 variables in here that we added. We want to add all sliders. Okay, and then it says under add slider, click all, click on the points on the graph that crosses the x-axis to show you the x-intercepts. So right now, there's just that x-intercept. Okay, and then experiment with moving the sliders around. What changes? So just move these around. See what happens as you do it. Okay, and you can zoom out. This is super zoomed in. I forgot about that. So you can zoom out to see what's going on. And so just answer those questions. Then it's going to want you to do, it's going to want you to graph each of these functions. So let me clear these guys out. What it's doing in this table is it's actually assigning numbers to these p-values. So 2, -1, and +4 are the first one. And it wants you to write the intercepts. So I'm going to go down, I'm going to click on my x-intercepts. And notice I'm going to have -4, 0, -2, 0, and +1, 0. See if you can find any relationships between the given function and the intercepts. It asks you that right here. What pattern do you notice? Okay. And then in step 8, it says graph the each of the following functions and fill out the table. So you're doing the exact same thing again. And then it says, does the function touch or cross at the x-axis? So let me give you an example. You guys should, sorry, also it's like 9:30 at night, so I'm exhausted. Um, so sorry for all the yawning. So what you guys are gonna do is type in one of your functions. Let me give you, I'm gonna do the second one down, x plus, oops, sorry, plus 2 x minus 1 squared. So remember that crosses is something like this, the -2, 0. Touches is something like this, the +1. And so it asks you, does the function touch or cross at x equals 1? So I want you guys to answer that question. For this particular one, it's going to just touch. Okay. And at x equals 1, it's just talking about this particular spot. Okay. So you're looking for patterns again there. And then for each function below, this is kind of like practice. So in step 6, 7, and 8, you guys should have come up with some good conclusions to tell you what values should go right here, or what, I guess, words would go right here. And yeah, so do your best with that. And then on the very back, you have practice. Okay. So I will definitely be grading this. So I want you guys to do all of this. I will post solutions to it tomorrow. I'll do the first one with you right now. So it says graph below an example of a cubic function with a positive leading coefficient. So let's see here. I'm coming up with one real quick. Let's see. So remember, so you guys, I guess we haven't really talked about this yet, but a positive leading coefficient is going to end up showing you that your end behavior starts low and ends high. Okay, as we move from left to right, we're going up. And so a cubic function is going to look something like this. And it's gonna, with a positive leading coefficient, it's gonna start going down on the left and then end up going up on the right. Okay, so I kind of gave you some answers to some stuff there. But that's an example of like what you're gonna do. It doesn't have to be a specific function. I just made that one up. So yeah, so these practice problems are not too hard, but I am going to grade them. Okay, so make sure that you get those done. I will be looking at your work. Remember that you need to be able to take pictures. If there's an issue with that, please email or remind me, and I will figure out a different solution for you. All right, I miss you guys so much, and I hope you're doing well, and I will talk to you guys again tomorrow.